Hello, Year 10. Welcome to another video. Today we're looking at multi-stage independent events. So an event is just something that can occur that might have multiple different outcomes. Multi-stage just means we have multiple events occurring in a row. So it might be at the same time, or it might be one after the other. Now, independent, as you can see here, means that the result of each of those events are not affected by the other. So it doesn't matter what the outcome of one event is, it's not going to change the probabilities for the outcomes of the other event. Later on, we're going to look at dependent events. Today, we're just looking at independent. And independent ones are easier to calculate because basically the probability, so we should be familiar with this notation here of P brackets and then inside the event. So if we have an event A and then an event B, so they could be anything, it could be tossing coins or rolling dice or anything whatsoever. The probability of A then B is going to be equal to the probability of A multiplied by the probability of B. Okay, so that's the key thing that we need to know. If we've got a chain of events happening, we multiply their probabilities to find out the probability of them all occurring together. And that's the reason why. So if you think about your probabilities as a fraction less than 1, if you have multiple events occurring in a row, if you're trying to predict the outcome of all of those events in a row, your probabilities are going to get smaller and smaller because every time you multiply by a number that's less than 1, your number gets smaller. So that's why multi-bets, you're much less likely to get a return for those bets because the probability of multiple things occurring in a row is much smaller than those probabilities individually. So something to be wary of when it comes to gambling. But here, let's look at an example. So a coin is tossed and a dice is rolled. So two simple events. Calculate the probability of getting a tail and a 6. So all we need to do to calculate this is multiply the probability of the tail by the probability of rolling a 6. So it's simply going to be a half. So you got 1 out of 2 for tossing a coin, multiplied by 1 out of 6 for rolling a 6 on a standard 6-sided dice. And that's going to be 1 out of 12. Okay, just multiply top with top, bottom with bottom when you're doing fractions, and you get your probability of the total event. For B here, a head and an odd number. So the probability of getting a head is a half as well. Probability of getting odd number 1, 3, or 5 is a half, so 3 out of 6. So we end up with 1 over 4 as our probability of that. And then the probability of getting a tail and a number greater than 4. So greater than 4 includes 5 and 6. That's 1 out of 3 or 2 out of 6. So we've got a half for getting the tail, and then it's 1 out of 3 for getting a number greater than 4 on a dice, okay? Because 2 out of 6 options is the same as 1 over 3. So we end up with 1 out of 6 for our answer for that one, okay? So just multiply the two probabilities together to get the total probability of all of those events occurring. All right, now when we have a bag here, we've got 2 bags, one with 3 white and one with 4 red balls, and the other one has 2 white and 3 red balls. So a ball is chosen from each bag. The probability of getting 2 whites, so for the first bag, is going to be 3 out of 7 for the first white, and then it's going to be 2 out of 5 for the second one. Now, the reason why that was the case is we have 7 balls in total in the first bag, and we have 5 balls in total for the second bag. So here we should get our calculator out, and we should go 3 over 7 multiplied by 2 over 5, and we can get our probability that way. Now you could just multiply top with top, bottom with bottom, and you get the same answer, 6 out of 35. Okay, for part B here, the probability of getting 2 red balls is going to be 4 out of 7 this time, multiplied by 3 out of 5. So this one would be 12 out of 35 in total. All right, I want you to pause the video, see if you can work out C, D, and E. And when you've done that, unpause the video and see how you went. Okay, so let's go through it. For C, a white and a red ball in that order. So the first bag, I assume we're referring to the first bag for that first one there. Obviously, it is important that you get the order right with this one. So I'm going to assume that they're talking about the first bag for this first one. And then it's going to be 3 out of 5 for this one. So we end up with 9 out of 35. And then for D, a white and a red ball in that order. So again, assuming that the first bag is this one in any order. Okay, so this is actually an interesting thing. So we need to consider all of the different ways that we can get this. First of all, we could get it the way that we did it originally, so 3 out of 5. And that would be if we got a white and then we drew a red. Now, there's actually another way that we can get that. We can draw a red in the first one and then a white in the second one. So what we actually have to do, because there's two different paths that can give us this outcome, we actually add the two probabilities together. Okay, so when you've got multiple events occurring in a row, you multiply them. But if you've got two different paths that get you to that outcome, you need to add those different paths. So we're also going to add this here. So it's going to be a red ball first out of 7 multiplied by a white ball, 2 out of 5. And this will give us 9 out of 35 plus 8 out of 35, which then we add the top together and we get 17 out of 35. Okay, so just to explain that again, we need to account for all of the different ways that you can get the outcome of a white and a red ball in any order. So we could get a white ball and then a red ball, and that's what this probability shows. But we can also get a red ball and then a white ball, which is what this probability shows. And so we add those two together to get our final probability. In the last example here, at least one white ball. Okay, now what we can do is we can do a little trick here. We can think about the complement of the event. So remember, the complement of the event is basically the opposite and of the probability of that not occurring, essentially. And that's going to be, if the probability of something that's certain is 1, then we know that the probability of something occurring plus the probability of it not occurring have to equal to 1. So that's how complements work in probability. Now, because that plus that equals 1, we can also say that the complement can be 1 minus the probability of the event. So what we can do here is we can work out what the probability of getting no white balls is, and then do 1 minus that probability. So the probability of getting no white balls is the same as getting 2 reds. So I can do 1 minus red, which is 4 out of 7, times 3 out of 5, which would be 1 minus 12 out of 35, which basically means all of the other parts there. So it would be 15 plus 8, 23 out of 35 would be the probability of getting at least one white ball. Now, if you pause the video and you had to go with that, you may have had difficulty with D and E, so you can re-watch this video if you need to go over how I did that. For part D, I added two different things together. For E, I did the complement. So I found out the probability of getting no white balls, which is the same as 2 red balls, and then I took that away from 1 to find the probability of getting at least 1 white ball. Okay, thanks for watching. Good luck with the questions. Shoot me an email or use the social stream if you got any questions on how to go about these ones. And I'll see you in the next video.